Hello, sir. My name is Varun Salgarkar and my registration number is 19BCE1435. So, today we are going to discuss about Apriori using RapidMiner. RapidMiner is a simulation software. First, let's get to know about what Apriori is. Let's understand it by an example. Apriori is all about finding the probability that if a person does X thing, how likely is he going to do other thing? Didn't explain quite much, right? So let's take a better example. Like suppose there is a supermarket and the supermarket sales has gone very low due to pandemic. But now he wants to boost his sales to generate a little income. So he can hire an ML scientist and he can just provide the previous month's data and he can help through using the a priori algorithm. How will it help? It will help in a way that it determines that if a person is buying X thing, like if a person is buying milk, how likely is he going to buy another thing? Like if a person is buying milk and if then the person is also buying bread. If a priori algorithm suggests that there is a high probability that this happens, the supermarket own what the supermarket owner can do is he can place these items so far away that like when the person buying milk and he has to travel a long way to buy bread, so on his way he will also pick up a few items which weren't on his list initially, so this will help boost the sales. Now this was what a priori is about. So talking in technical terms, the support, confidence, and lift are the main things that we need to understand in a priori algorithm. What is support? Support is just like if there are 100 people and out of those 100 people, 10 people buy milk, then the support will be considered as 10%. What is confidence? Confidence is if people are buying milk and also if the probability that if a person buys milk and also buys bread, that is the confidence. And what is lift? Lift is confidence upon divided by support. So the higher the lift of two items is, the more probability is that the person will buy both the things. So this is the a priori algorithm. Let's get to the implementation part. So the data set that we are using is quite large. So we need to pre-process the data before feeding it into the simulator. For this purpose, we are using the pandas and MLXN library. Pandas is going to help us a lot as it usually does. So first, what we are doing is all the row values present in the data set. Uh, we are appending them to the transactions list. So this is we are printing out first four values to understand how the list looks like. So the person one is buying burgers, meatballs, and eggs, and the person two just buys chutney. Person three buys turkey and avocado. So now, as we can see, we don't need these nan values. So we will remove those nan values, and this is how the output looks like after removing the nan values. And as the dataset has 7501 rows, it is quite a lot. So, and a priori is kind of slow algorithm, so it needs a lot of time. So we are just using first 75 values for training our data. So what transaction encoder does is it takes this list and it just fits in to produce an output like this, and this will be now further fed into the simulator. Let's get to the RapidMiner. So this is how basic interface of RapidMiner looks like. This is the data set how it was initially. Even the first row, it did not have any description or anything. It was just what people bought. So we aren't using this one. This is the data set that we are using, which is much more organized and clean. And as we can see, it is just binary, like one and zeros everywhere. So it suggests like row number suggests the customer, and if avocado states one, it means that the person one has bought avocado, and number zero states that the person hasn't bought any of those things. So that is how it is. So what we do first is we just take this data that we have processed and we put in here. This is the same thing we have done. And as we can see, as we saw earlier, our the data, how it looks like was this is how the data looks like. But the predictive a priori needs true or data in terms of true and false. It is easier for it to process. So we changed this numerical data into binomial data, and it just instead of zeros present in here, it will turn into false, and all the ones will turn into trues. Now this data is fed into W predicted a priori, and we just attach it to the result. When we run this thing, this is the output that it is giving. So as we can see, it gives 78% accuracy, and it states that if a person is buying spaghetti and turkey, then the person is more likely to buy mineral water. Similar is for if a person is buying chocolate and eggs, he will also buy again the mineral water. Now this is just we have used this to give just 10 values. We can change this and we can see first 20 association rules. We just hit enter and run. So now we can see it has given 20 association rules. So we can generate as many as we want. But as we can see, the as we go downward, the accuracy goes on decreasing. So in order to be in the uh, optimal range, one should consider how much, according to accuracy, how much he wants to play with the results. So this was using W predictive a priori. If we delete this and if we use FP growth now, let's see what FP growth gives result. So we just connect the binomial data to FP growth and create association with it. We pair it to the confidence and run. Okay, yeah, sorry. So as we can see, the FP growth for FP growth wasn't able to produce results for some reason. So that was how it is. So we have also I've also done it using Python. I've used the Apriori library. So as we can see, if it is the same data set, but here I've used the whole data set, like all 7501 rows and 20 columns. So as we can see, if a person is buying fromage blanc, he will buy honey, and the lift is also quite high. So this is how a person can use a priori to profit in business, and it can be used on other grounds as well. So this was all about it. I hope you like, sir. Thank you.